In example 3, we're asked to find the sine of angle S and the cosine of angle G. And so when I go and I identify angle S in my triangle, and I remember sine is opposite over the length of the hypotenuse, well, in this case I don't actually have the length of the hypotenuse, but I'm given the other two sides of the right triangle. And so I can actually use Pythagorean theorem to solve for the length of the hypotenuse. And so Pythagorean theorem says that the two sides of the triangle, the sum of the squares of the two sides of the triangle, should equal the length of the hypotenuse squared. So A, B, and C, A and B are representing the legs of the right triangle, whereas C is representing the length of the hypotenuse. And so in this case, I would put 16.2 squared plus 21.6 squared should equal my hypotenuse squared. And so 729 rather should be equal to the hypotenuse squared. I can square root both sides to find out what C would be. That turns out to be 27. And so the length of my hypotenuse is 27, and now I'm able to figure out what the sine of angle S is, because I have the length of the hypotenuse now. So sine of angle S is the length of the opposite side divided by the length of the hypotenuse. And so again, we should always try and rewrite this in lowest terms. We don't really want to write decimal numbers in a fraction. And so this turns out to be 0.6 or 3/5.